In this video, I will show you an example of what happens when a function is rotated about another horizontal or vertical line besides the x-axis or the y-axis. So very important, I recommend that you always draw a diagram to help you visualize the radius. In this example, we're going to find the volume generated by rotating the area bounded by y equals x squared, the x-axis, for the domain from 0 to 3, and we're going to rotate it about the line x equals 3. So let's first start with graphing our y equals x squared, our parabola. So we have 0, 0, 1, 1, 2, 4, and 3, 2, 4, 6, 8, 9, which I'll plot over here. So I'm stopping at 3, because it only goes from 0 to 3. And we're going to rotate about the line x equals 3, which is this dotted line I've drawn here. So let's draw the parabola. And when I rotate it, I will get the symmetry on the other side of the axis that looks like this. And it's going to be circular like that. And I'll have something kind of like a cone, kind of like a wizard's hat, I guess. Now, what we're going to do next is we need to find our radius, because remember, to find the volume of a solid, it's always going to be pi r squared. Now, if we take a look and compare this to what we've done before, this axis is parallel to the y-axis. So therefore, I need to write my function in terms of y. So I'm going to rewrite this as plus or minus root y equal to x. Now, if you look at this drawing here, the radius is from here to here. And no matter where I pick the radius to be, it is always going to be dependent on my x. So the x is the distance from here to here, which I can find based on my function, which is x is equal to plus or minus root y. So we're going to take the positive root y, because this is what this side of the function is. So if this x here is equal to root y, but I also know that the distance from here to here is 3, then the radius is going to equal 3 minus x. And this is helpful to now rewrite this as 3 minus x is root y. Now I can say that my volume is going to be the integral from 0 to 9, because we're rotating about a line that's parallel to the y-axis, so we need our y limits. And it'll be pi r squared, so r in this case is equal to 3 minus root y. So we have 3 minus root y all squared dy. So pulling the pi out, I want to integrate from 0 to 9, but before I do that, I want to expand this square. So I'm going to get 9 minus 6 root y plus y dy. All right, so now let's integrate. So this will give me 9y, and this will be 6y to the half. So we're going to add 1 to give me 3 over 2 over 3 over 2 plus y squared over 2, integrating from 0 to 9. So when I plug in the 9, I will get 81. And here I have 6 divided by 3 over 2. So that's actually going to be 12 divided by 3, which is 4. So I'm going to have 4, and then I'm going to plug in the 9 for the y value. So I get root 9 cubed. And then over here I get 9 squared over 2. So the volume is now equal to 81. So root 9 is 3 cubed, 27. 27 times 4 is 108, plus 81 over 2. Combining all of these numbers together inside, I'm going to get 27 pi over 2, which I've pre-calculated on my calculator. So this will give me 27 pi over 2 units cubed. So I think what's useful here to remember is that you want to find the distance from the axis to maybe your main axis, which is our y-axis here, and that was a distance of 3. Label where the radius is and what it is, the x or the y value that you can find. So in this case, we know what the x is based on our function, and you will always know either x equals or y equals to help you find that. And then you can use some combination of adding and subtracting to actually find the radius. Sometimes it's increased, and sometimes, like in this case, as decrease. So normally we would have, if you take the radius in the very bottom of this hat, it would be a radius of 3, but then it gets smaller. So it would be 3 and then minus whatever the increasing x value is.